The empirical rule is also known as the 68, 95, 99.7 rule. And this is an easy way to break up the normal curve and to kind of have an estimate of where things lie. So as you know from earlier, the normal curve represents 100%. So all of your data, if it were perfectly normal, would lie within that normal curve. Our mean and our median divide our normal curve in half. I'm just going to call that our mean, but if it's a normal curve, the middle line is going to be both your mean and your median. Now, in a normal curve, the majority of our data lies within 3 standard deviations of our mean in either direction. So I'm going to draw that in. So this represents 1 standard deviation away, 2 standard deviations, and 3 standard deviations. On the left-hand side, it's the exact same thing, except those are represented by negative numbers. But it's the exact same thing. It's still 1 standard deviation away, 2 standard deviations, 3 standard deviations. So the 68 portion of our empirical rule states that 68% of our data lies within 1 standard deviation. So if I were to draw that in here, and I'm going to switch colors just to make things easier. This whole middle section, and pretend it's even, I know my drawing's horrible here, but within 1 standard deviation, 68% of our data lies within that 1 standard deviation. From there, let's look at the 95. The 95% represents 2 standard deviations. And that rule states that 95% of our data lies within 2 standard deviations. So notice it includes that 68%, but it also represents another standard deviation on the outside. So when you're looking at data, 95% of your data, so all but 5% of your data lies within 95% of that, or within that 2 standard deviation range. So 95% of your data is within 2 standard deviations of your mean. And finally, the 99.7% represents 3 standard deviations. So 99.7% of our data lies within 3 standard deviations of our mean. So this area shaded in blue is 99.7%. That tells you that this little teeny tiny bit left over in the tails only represents 0.3% because we add up to 100%. So a total of 0.3% lies in our tail, or 1.5% on either side because it's symmetrical, so both sides are equal. So very little is left on the outside of our diagram.